the flowchart structures. We've got three different types of the structures, but simply the control structure means how the program is executed, or the order program is executed, or it describes the flow of execution. For example, from this line to this line, this step to this step, the steps of the execution. And we've got three types of the control structure. They are sequential, selection, and repetition. At the first time, you are going to talk about the sequential. So what is sequential structure? There are some steps and some statements in each algorithm, and they are executed in the order that they are written in the algorithm. For example, for when you are saying calculating the multiplication of two numbers, we are getting those two numbers and then calculate the multiplication and then produce the result. That means the order of the execution. For example, here we've got start and we've got end at the end, or the stopping point of the algorithm. Then statement 1 is executed, then statement 2, then statement 3, up to the end statement. Then the program goes to the end, or the algorithm goes to the end. And what is the main important element of each flowchart? The main important thing is a statement, and multiple statements can be considered as one statement. For example, here this statement, and we know that a statement is an instruction, is a command, or is a process. So those two statements together can be written inside only one statement. Okay, and then how to trace a flowchart. For example, here there is a flowchart to calculate the area and the perimeter of a rectangle. So in order to calculate those two things, we need to get the length and width. So we are getting them as input. For example, we are initializing them a length as 5, width as 3. Then calculate the area and calculate the perimeter. Those things are processes or commands or instructions based on their own formula. Area is length multiplied by width, while the perimeter is 2 multiplied by width plus length. So we can form both of them in one statement. Okay, then when we done the process, we are going to print the area and the perimeter of the rectangle. Then we are going to the stop, and you know that this is the input phase, this is the process phase, this one is also a process phase, and this is an output phase, and this is the stop terminal, while this one is the starting terminal. Okay, a trace table is something useful for the developers or the programmers to test their program or algorithm in order to make sure that there is not error or there is no logical error inside their program. And within this table, we need to have the variable, the inputs, and the conditional tests and the outputs inside that table. For example, belongs to the previous flowchart, which calculating the area and the perimeter of the rectangle. We needed to have length and width as input, and then we calculated the area and calculated the perimeter, and then we shown the output. For example, if the length is 10, the width is 15, the area is going to be this one based on the formula, and perimeter as well is going to be 50 based on its own formula. Then we are going to show the area and the perimeter. Then we are going to test our program for the other values, and then calculating the area and the perimeter and showing them. So we need to make sure that everything here is right. Then you can publish your program, and you can say that my program is all right. This is an exercise for you. You need to do the trace table for yourself in order to make sure that your trace table or your program is completely true or false. So you are going to determine you are going to calculate the area of the circle based on this formula, while the radius is 3, and the next time is 10, and the last one is 150. So the pseudocode is going to be start, set pi at this number, this is constant. So we are going to read the radius, so calculate the area. Area is radius multiplied by pi, then display the area. So you are going to apply the trace table on this algorithm when you have the radius 3 or 10 or 150. Another example, we are executing this flowchart and writing the trace table for these values, while the n is 89 or 26, then 0, then 3. For example, I am calculating this one, I am performing this one for you, then you can do the trace table for all of them. So start, read n is 89. 89 modules 2 equals to 0. No, it's equals to 1. So that means it's not true, it's false. So n is odd number, that means 89 is odd number. Then the program comes to end. The second type of flowchart structure is selection. So selection allows you to choose between two more alternatives. For example, sometimes you come to some point, you have two possible solutions. You have a condition. For example, the number is positive or negative, or the number is 0 or not 0, the number is even or odd. Or so we've got so many examples, we are going to describe them in the next slide. So why to do this? The decision made by the computer must be very simple. Why? Because the computers are working on only two values. They are 1 and 0. They are true and false. So when you are facing some complex decision, so you need to reduce this complexity by yourself so that the computer can handle. Some problem example of the selection structure, for example, determine whether profit is capital or loss. For example, determine whether number is even or odd, whether a mark is less than 60. If less than 60, then fail, otherwise pass. For example, if the speed limit exceeds 110, or if or not. If it exceeds, then fine $300 or any other thing like that, otherwise fine 0. Determine whether age is above 12 years old. If the age is above 12, then ticket is 220, otherwise ticket is 10. Then display the ticket value or stuff like that. The selection structure inside the pseudocode requires if statement. Okay, this if condition. For example, we are saying if this condition is true, execute this statement, and if it is true, then execute this statement, otherwise it doesn't execute this statement. For example, here we have the flowchart example. For example, here the program comes to this condition. If this condition is true, then this statement is taking place, this statement is executing. If it's not true, if it is false, the statement is not executed, it directly goes to the next step. And the whole thing, the whole if condition with the statement can be forming up with only one statement.